In this video, we are going to work with probability and calculate the minimum and maximum number of people in a particular study who favor a certain situation. So in this first example, a study determined that 28% of high schoolers favor math class over PE. 28% of all the high school students that they surveyed favor math class over PE. Now that margin of error for that particular survey was plus or minus 2%. So that means it could be off by 2%. So the 28% of students who favor math is given. So I'm just going to jot that down. 28% favor math. And it says the margin of error is plus or minus 2%. So that means there could be a max of 30% or a minimum of 26%. So plus or minus, I'm going to use a highlighter here, plus or minus 20% to the 28% would give you your 30% and your 26%. 30% obviously is a high and 26% is a low. Then it tells us that if 1,500 students were surveyed, what's the minimum and the maximum number of students? So the maximum of 30% would be 30% of 1,500 students. And of means multiplication. So they'll give you a percentage of a number, a percentage of a number, and that of right here means multiplication. So when you see that percent of a number, you're going to multiply the percent by the number. So 30% of 1,500, I put that into my calculator, and when I put that into my calculator, I'm going to put 0.30 times 1,500, and that gives me 450. So 450 students max. Now the minimum is going to be 26%, so 26% of 1,500 would be 0.26. We're going to make that percent a decimal, multiply it by 1,500. Put that in our calculators, and if I calculated correctly, I got 390 students minimum. So the maximum is 450 students, and the minimum is 390 students. Okay, let's try that again. A study determined that 63% of fifth graders favor the color green over red. The margin of error is plus or minus 5%. If 2,800 children were surveyed, what is the minimum and the maximum number of children who favor green instead of red? So let's do this in order this time. So I'm going to say the minimum and the maximum. We know that 63% favor green instead of red. So a minimum would be 63% minus the 5%. 63 minus 5 gives us 58%. So 58% of 2,800 children were surveyed. So 2,800 is what we're going to be multiplying by. That's going to be 0.58 times 2,800. Take out your calculators and make sure that you get 1,624 for a minimum. Now maximum, you're going to take your percent of 63%, and you're going to add that margin of error. So that's going to be 68% of 2,800 students. So 0.68 times 2,800 is equal to, I got 1,904 max, but please check in your calculators. So for a minimum, 1624, and for a maximum, 1904. Okay, the next one is for you to try. So go ahead and press pause. And then when you're ready to check your answers, press play. Okay, welcome back. For minimum, I got 34% plus 3.5%. Is equal to 37.5% of 4,200 families. And I actually put that in my calculator wrong, so I'm going to do a quick calculation here. 0.375 times 4,200. 0.375 times 4,200. I got 1,575 for a minimum. Maximum, that's a maximum. Because I added first, so that would be a maximum. And then for my minimum, I would have 34% minus the 3.5%. So 34 minus 3.5 would be 30.5% of 4,200. 0.305 times 4,200, and I got 1,281 as a minimum. So I did this a little bit backwards. My maximum, which I'm going to keep my maximums all green. My maximum is up here, and the minimum is here. And I guess, depending on how your brain works, you know, if you're thinking of adding that margin of error first, just know that when you add, you're getting a maximum. And when you subtract that margin of error, you're getting a minimum. So in the first problem, I did calculated the maximum first, then the minimum. In the second problem, I calculated the minimum and then the maximum. Showed my work, how I did that on the second example, and on the try, my brain was working with the maximum first and then the minimum. So as long as you're labeling which one is which, the higher number is going to be your maximum and the lower number is going to be your minimum, you're good to go.